In this video, I'm going to show you how to get access to the bootlock of a Turing PI node. In other words, how to access its serial console. Now here are some timestamps for those who cannot wait and want to skip ahead. And with that out of the way, let's get started. I am Garrett and this is TheFatRat. First, let's talk about serial access. What is serial access? Serial access is a way of communicating with devices on a very low level. It's used for devices like Arduino, Raspberry Pi, you name it. Even routers, switches, even nowadays, still have serial access. It's a very simple and extremely reliable communication way of interacting with devices. And the Turing Pi supports this too. And the Turing Pi supports UART. And UART stands for Universal Asynchronous Receiver Transmitter. Now, what it all does is serial access, when you're communicating with a device, sends one bit at a time. So it sends a start bit, and then every bit will follow in sequence. So instead of, for example, when you send a text message with your phone, you write a text message, you press send. And that is not how serial access works. Serial access would take that text message and send one character at a time. One character, send, one character, send, one character, send. So that in short is serial access. And we can use this to show the bootlock because the Turing Pi doesn't have a monitor attached when we're booting up. This way we can see the bootlock when a node is turning on. If there's any issue, we can investigate. All nodes you plug into your Turing Pi will support this. And the reason for that is it's supported from the BMC to the node. So the BMC provides you with this functionality. Now there is a caveat that the Raspberry Pi does support it, but it is not activated by default. So when you have a Raspberry Pi node, you need to make a tiny change before you can use it. I'm going to show that first. I'm going to tell you quickly how to activate that in case you use a Raspberry Pi. Otherwise, you can skip ahead and get started. Here's the timestamp to jump ahead past the Raspberry Pi section. And let's get started. In order to use a Raspberry Pi in combination with UART, you need to enable it. Now, this is not really hard. You need to make a change to the boot configuration of your Raspberry Pi node. Now, in order to do that, I have made a video how to access a node storage device. Here's the link to that video. And when you do that, you can mount the boot partition, so the first partition. Then what you're going to do is you're going to change config.txt. This is the boot configuration of your Raspberry Pi node. Now, what you're going to do is you're going to search for a section called all between square brackets. And in that section at the bottom, you're going to add in the following, which is enable_UART equals 1. This will activate and enable UART for your Raspberry Pi node. And with that enabled, we can now get started. Let's talk about what we will be doing. So we're going to need two terminals. The first terminal we're going to put into listening mode. That's where we're going to see all the output of the node while it is booting. And we're going to use the second terminal to issue the boot command to start up the node so that we can see the output in the first terminal. Before we continue, we need to talk about something important, which is node device allocation. So we need to use a serial device on the BMC to get access to the serial console of a node. Now, there are two versions of the Turing Pi, version 2.4 and the latest version 2.5. And between those versions, there's a difference when it comes to the node device allocation. Now, here's the node device allocation, and let me run you through it. So what you can see is that in version 2.5, they fixed the problem which is apparent in 2.4. So in version 2.4, you can see that the slot of the device does not match the serial device. So, for example, you can see that node 1 uses serial device TTY-S2. Node 2 uses TTY-S1, node 3 uses TTY-S4, and node 4 uses TTY-S5. Now they fixed this in version 2.5, where they made sure that the node slot matches the serial device. So node 1 is TTY-S1 and node 2 is TTY-S2, etc. Now, please make sure that when you will be accessing the serial console of a node that you check your version of your Turing Pi and that you use the correct serial device for the node slot you're trying to access. So with that out of the way, we finally can get started. You enjoying the video? Comment below, subscribe and hit that like button. It greatly helps this channel out. Now, let's get back to the video. We're finally ready to get access to the serial console of a node. Now, I'm gonna access node 1 for this demonstration, and I'm gonna use the corresponding device for that. And I have a Turing Pi 2.5 on which I'm gonna show you guys this. Now, please take note that if you need to know which serial device corresponds to which slot regarding the Turing Pi version you have, please jump back to the node device allocation section where you can see which serial device belongs to which node. Finally, I have updated my terminal so that it would be easier to see and that during the edits of the videos, output is no longer hidden if I'm at the bottom of my terminal, because in previous videos I sometimes forgot to clear the terminal. So I fixed that. So I hope you will be able to follow and see everything regarding the output. Now, without further ado, let's jump to our first terminal. Welcome to Terminal 1. At the bottom, I will put the most important commands so it's easy for you to follow along or just to scroll back and actually read the commands that you need to be using. So the first thing we're going to do is we are going to log in to our Turing Pi using the username root and the standard password Turing. Now we are in our BMC. Now I'm quickly going to show you where the serial devices are. They are located in the devices folder in /dev. So what you can do is you can go to the device folder and then ls/ttys*. And this will give you the device. Now, as you can see, I'm doing this on Turing Pi 2.5. And that means that number 1 to 4 of the serial console device matches the node slots. This is different for the Turing Pi 2.4. Please note that if you do not know which one you need to use, please jump back to the node device allocation section where you can see which serial console belongs to which node slot, which makes it a lot easier for you. Now I'm going to jump back to our previous folder, and you can do that, by the way, quickly with cd --. It will always return you to your previous folder. Let's clear this. Now, before I'm going to continue, you need to make sure your node is turned off. So let's check the current power status of our nodes, and all my nodes are off. In case you need to turn off your node, that would be TPI power min and 1 for node 1 and then off. And the node is now turned off. Now what we're going to be using is we're going to be using a command called picocom, which is a command to use for serial console access. And it's very easy to use. It's simply you picocom, then you have to give the device you want to connect to, which is /ttys1 in my case for node 1. And then you need to give the baud rate. And the baud rate refers to the number of signal changes or symbols transmitted per second. So basically, it's you giving it a speed limitation to make sure that everything works correctly. And for us, that would be 11.5-100. Hit enter and it will give you a bunch of output, but as you can see now it says terminal ready. So now it is simply waiting for output. Now I'm gonna jump to terminal 2, and here is terminal 2, and here we are gonna give the command to power up the node, and then we can follow it in terminal 1. So TPI power min and 1 for node 1, and we're gonna say on. Now, before I'm gonna hit enter, I'm gonna switch back to node 1 so you can straight up see directly what's happening. And when I hit enter, everything should go smoothly. So before I hit enter, I'm gonna switch back for you to terminal 1. So here's terminal 1, it's still waiting for output. And now in my second terminal, I'm gonna hit enter. And I forgot to log in. So I forgot to do an SSH connection to the BMC to directly give the TPI command. And now I have to do it for my machine. So user root password Turing, and here we go. And there we go. And as you can see, it's booting. You can even apparently stop the auto boot. And everything is going pretty smooth. And there's the kernel. And the OS is now booting. Let's see how fast it will run. Well, and there we have to log in. So node 1 is boot up. We got to see everything during the boot process. Now you can actually, let's see, you can actually use now picocom commands to actually log into the node. So I believe the login was Ubuntu, and the standard password was, I believe, Ubuntu. First time you have to change it. I just refreshed it for this demonstration. Current password, Ubuntu, and I'm setting a new password. And that's it. Now, how do you exit? Because everything, even Command C for normally for interrupt, is being sent to node 1. Well, how do you exit picocom? Kind of important to know. You're gonna hit Control A, hold down, still hold down Control, keep holding Control down, release the A, and then press X. So Control A, then you keep holding down Control, and then you press X. So Control A and then X. Thanks for using picocom. And that's it for this video. I hope you enjoyed it. Comment, like, subscribe. Greatly helps this channel out. And I see you guys in the next video.